right, thanks very much. Thanks for inviting me to be here. It's been a great meeting, and I'm looking forward to our conversation. Tried to do too many things, so I'm gonna go quickly through some things, and happy to talk about any parts of this that you want to talk about. I'm going to talk a little bit about why what you do is amenable to concerns about justice. Then I'm going to talk about what the ecosystem of innovation is, what I mean by that, what its determinants of health are, and then I'm going to make an argument for you that the ecosystem of innovation surrounding AI is unhealthy in a way that needs to be changed. So first, why is what you do amenable to concerns about justice? Partly that is because research engages and draws into convocation important social institutions. So these are things like funding agencies, research institutions, academic institutions, government agencies, healthcare institutions, educational institutions, policymakers, regulators. They draw on the research that we do, draws on scarce resources, so you have to get your money from somewhere. It's people's time, effort, resources, human, material, financial, the prestige and trust, like you're part of institutions whose prestige and trust comes from the fact that they support research. It's very different if you're like there are other institutions like used cars where their lack of trust means they're a low status, but your carrying out research is a high status thing in our society. These institutions have a social purpose, so they're not just there for the taking. They're supposed to create a distribution of labor that generates knowledge that's necessary to close important knowledge gaps in society. So this is why we support the institutions of scientific advance. So we're trying to bridge gaps between institutional capabilities, so our ability to understand people, meet their needs, whether that's their mental health needs, their physical health needs, their nutrition, dietary needs, their infrastructure needs. And scarce resources are supposed to serve those purposes. They're not free for the taking. They're also subject to claims that must be redeemed. So low quality research is then subject to criticism, that we should be trying to find ways to funnel our money towards better, more high quality research. Also, the research outputs that we generate feed into institutions and the decisions that they make. So societies, institutions rely on the information that we generate for treatment practices, standards of care, funding and reimbursement decisions, subsequent research trajectories. So what questions are live, what questions aren't live, what sorts of things we feel like we should explore or shouldn't explore. We rely on this information to make policy, to do, for regulatory funding, and individuals shape their preferences as we develop information that says some certain practice, like, replica and the conversation we've had, if that's harmful, that might change my attitude towards it. If we say it's not harmful, it might change my attitude in a different way. And then research outputs shape the way society utilizes its resources, so that funnels back into how people's time and effort and resources and stuff like that are used. Okay, so this is by way of saying the research enterprise is subject to claims about justice. And then now I want to say, so if the innovation ecosystem is unhealthy, then that's going to give rise to claims of justice. So what do I mean by innovation ecosystem? So this is the system of institutions, stakeholders, and incentives through which social and epistemic labor is divided to produce the knowledge that's necessary to close these important knowledge gaps, right? So by the health of the innovation ecosystem then, I mean the extent to which those incentives and structural or strategic relationships align stakeholder conduct with practices that make efficient use of these resources to close these knowledge gaps so that we can then implement findings to the benefit of various stakeholders. So the determinants then of the health of the innovation ecosystem are going to be things like, to what degree is it resistant to cooptation? So powerful parties want to co-opt this infrastructure for their own parochial purposes. To what degree is there an alignment of incentives so that researchers have incentives to do high quality research that will advance the needs that we were talking about? Do people have calibrated expectations so they understand what tools are, what they can do, where they should be used to proper benefit? Do we pursue high-value questions in what we do? Are we making efficient use of resources? Is our work high quality, so it's got high internal validity, it's got high external validity, we control for confounding, so we think we're getting causal relationships when that's what matters. And then do we uptake these findings in order to make the things, the practices that we do better and more efficient in some way? So these are the things I want you to keep in mind then. That if these are the determinants of health for the innovation ecosystem, now I'm going to start talking about AI and why I think the innovation ecosystem surrounding AI is deficient in some of these features. So one is that hype can undermine the health of the innovation ecosystem, partly because it produces miscalibrated expectations. That can also lead both indirectly and directly to a misallocation of time, effort, and resources, and a misalignment of incentives. And if powerful parties can steer the hype, then they can co-opt important social structures for their own parochial ends, and so that also produces a misalignment of incentives, and it produces a higher probability of low-quality work. So in some ways, hype sits at the center of this network of things that can affect the health of the innovation ecosystem. So now I want to give you some concrete examples where I think we fall down. So here's the first, wishful mnemonics. So attributing capabilities yet to be verified. Emergent abilities was an older one. We don't hear about it as much, but that was really big at one time. Zero-shot planners. Reasoning is quite popular right now, and agents is sort of the main one. Bandwagons of hype and the outsized influence of product vendors. I'm just giving you the list of the things where I'm going to give you more concrete examples in a second. And then benchmarks that have poor external validity. So things like meeting or exceeding human level performance. This is a really common claim. You will see we meet or exceed human level performance, and then insufficient oversight. So wishful mnemonics, this is great. So I'm just going to read these to you. This is a quote from a paper. If a researcher tries to write an understanding program, it isn't because he's thought, or she, sick, of a better way of implementing this well-understood task, but because he or she thinks that they can come closer to writing the first implementation. If they call the main loop of their program understand, that they are, until proven guilty, merely begging the question and may mislead a lot of people, most prominently themselves, and enrage a lot of others. What they should do instead is refer to this main loop as G0034 and see if they can convey to themselves or anybody else that G0034 implements some part of understanding. Or he could give it a name that reveals its intrinsic properties like node net intersection finder, it being the substance of their theory that finding intersections in network nodes constitutes understanding. So basically saying like, name this what you think it is, and then you have the burden of proof of showing us that this is what constitutes understanding, right? Do you want to take a guess? What year, does audience participation, I don't have much time, so just shout out. What year do you think this was written? 1967. Yeah, so that's good. What else? 82, yeah, so this was Drew McDermott in 76, right? So like this is a problem that is kind of endemic to my friends over in computer science. I mean, we can, so let me, and I'll try to come, like, I'm not just calling names, like we'll give some examples here. But so what does this look like to you? Audience participation, quick, shout out. What does it look like? A paper? Right? Research paper. Looks like a research paper. Here's a claim from this paper-shaped object. By contrast, modern generative AI takes self-supervision to the web scale. I hadn't really thought of that. Like, I guess, that's pretty big, though. Thus acquiring emergent capabilities. So there's emergent capabilities not seen in similar scale of pre-training in truly generalist fashion. So these are generalist models. Large language models such as GPT-4 have demonstrated unprecedented prowess in conversation reasoning, instruction following for new tasks without specialized training. So those are pretty amazing capabilities, right? This is in the New England Journal AI. New England Journal of Medicine, for those of you who aren't in medicine, is a super prestigious a high-impact journal. They have a spin-off called New England Journal AI. This has a DOI. Only research papers get a DOI. If you have an advertisement for a can of Campbell's soup, that cannot get a DOI. What does that say? That says sponsored content. The following does not appear on the PDF if you download the PDF and circulate it. But if you go to the HTML, it says, this paper, which should be in quotes, is sponsored content provided by Microsoft. It has not been peer-reviewed or endorsed by New England Journal AI and does not reflect the perspectives of the journal or its editors. Learn more about sponsored content and our business model here. So if you have a deep enough pocket, you can publish with a DOI a research paper-shaped object in one of the most prestigious families of journals. You can say the things that are said down there, and you don't have to go through peer review. If I want to do it, I have to struggle through peer review and hopefully show my peers that what I'm saying is justified. This isn't just one paper. There are 7 of them. There might be more. There were 7 at the time that I did this research. They all have DOIs. They all say things like precision health, revolutionizing. So zero, you can make outsized claims. No one's going to check your evidence, and it's out there masquerading as research. So this is a sign of an unhealthy ecosystem where powerful parties can co-opt important institutional structures to do their bidding. Now I want to talk about some of the ambiguities in some of these terms, and the one I'm going to pick on is emergent ability. So there's 2 ambiguities in emergent abilities, and so I'm a humanist. This is like some of you have a duck blind. You go out, you observe people. I'm a philosopher, so what I do is I analyze concepts. So there's 2 ambiguities here. One is in the notion of emergence. There's an epistemic dimension to it and an ontological dimension to it. What do I know versus what sort of thing is this? Then there's an ambiguity in ability, where there's a kind of task-related dimension and a capability-related dimension. And so we can create this 2x2 where if you're in the epistemic and task-related quadrant, then that means that this is just a mundane claim that as scale increases, one may not know how models' performance will increase on new tasks. Absolutely true, very mundane, really important point. If we talk about the task-related ontological point, then the claim is also relatively mundane, that the internal capacities of a language model remain the same. It's autoregressive, next token predictor. But the genuinely surprising claim that predicting the next token can be a useful approach to performing a much wider range of tasks than we might have initially thought. Also true, very, very true and important. On the capability-related side, the epistemic point is also the sort of mundane point that just says, hey, I might be uncertain as we increase in scale whether there will come about some surprising new internal capability. And that's also fine methodologically because we might want to answer that question. It's the capability ontological part that gets really disturbing, where it says this would be the amazing claim that at some new scale, systems develop new internal capacities in virtue of which they can better perform established tasks. So we're not saying they can perform established tasks through some other mechanism like next token prediction. We're saying something like next token prediction allows them to develop an internal capability like represent a chessboard, reason, and perform, plan. So the idea you're a zero-shot planner now means, oh my gosh, we've got this emergent capability that you can perform a wide range of tasks. So here's 2 papers that go in these different boxes. On the right, how many of you know the Sparks of AGI paper, right? So this is the paper that launched 1,000 ships, basically saying like, hey, we think large language models are showing the sparks of AGI. So look at all the things they say there, that they're unsupervised multimodal learners, few-shot learners, and so on. And in the other box is this absolutely wonderful paper called Embers of Autoregression. So both wonderful for the methodologically incredibly good work that it does, but also for their title really like riffing off the other title. So now that's what I want to go into. So the real genuine scientific question, like which box are we in? Are we in a world where these systems have these new internal capabilities where they can do all this fancy stuff? Because that's how we're being encouraged to talk when we talk about things being an agent or a reasoner, chain of thought reasoning, right? We're not doing like chain of thought mimicking the syntactic tokens that would look like reason. We're saying it's chain of thought reasoning, right? So here's what, from a kind of like DAG perspective, right? We've got how is this task being performed? So we've got these correlations among the syntactic elements in our training data. They go into the model, and then it could be that is what produces the correct answer, and that could be through memorization or pattern matching between the correlations between these tokens. Or it could be via some emergent capacity like representing the structure of the problem. So that would be this DAG down here, right? Where it allows us now to represent the structure of the problem or reason about the structure. So these are two very different models, and they have really important implications about robustness, where robustness is something like, what are the contexts in which I can expect to reliably use this? Clever Hans was a horse that could count, right? Like you'd ask Clever Hans, what's 2 + 2? And he'd be like, and you're like, oh my God, Clever Hans got it right. And Clever Hans got it right. But Clever Hans was only going to get it right if his owner was there doing the math in his head. Clever Hans, you can't rely on Clever Hans to arbitrarily solve any mathematical problem. And that's just the thing. If it's got the internal capability, then you can rely on it to solve problems generally. If it doesn't, then it's going to be a much more brittle type of thing. So Embers of Autoregression is one of the amazingly high quality papers where they take the notion of confounding and then say, this thing was an autoregressor. Let's look at and use hypotheses about how would an autoregressor work and where would it fail. And so you can do things like GPT-4 can only decode 3 of the most common shift ciphers on the internet, although the algorithm for solving them is the same. So a shift cipher is like if you want to type a message, but instead of typing the A key, you always move say down 1. So there'll be some algorithm like on the keyboard, move some number over whatever, and then you just, so instead of hitting an A, if you go 2 over, it's a D, right? And so that's how you create the code. So once you have the algorithm, if you're a reasoner, then all you need is the abstract algorithm, and you would apply the abstract algorithm to any shift cipher. But GPT-4 can only do shift ciphers that it's seen on the internet, the common ones. Once you say, hey, apply this into any of the other shift ciphers, it can't do it. So that's really good evidence that it's recapitulating something it's seen in its training data. It's not exercising this internal capacity to now generalize this algorithm to lots of other places. It's got sensitivity to output probability. So take a sentence, put it in, and then say, please write this sentence backwards. If it's a common sentence, it will do it. If it's an uncommon sentence, it can't do it. Whereas it's the same algorithm for every sentence. And sensitivity to prop formulation. So if you say, hey, what's 4 times 7, but you write it as the digits, versus you spell it out, versus you spell it very differently, performance of the model changes. There's a more analytically rigorous paper, the chain of thought reasoning is a mirage, where they show basically these same results, right? That performance degrades with novelty depending on the task and its latent structure, the length of the reasoning. So if you arbitrarily, you teach it, here's F1, here's F2, here's F1, here's F2. Now do F1, F2, and F1 again, and it's like, sorry, I can't do that. Well, I told you F1, I told you F2. Yeah, but I've never seen F1, F2, F1. These things are, so that's for reasoning. We also were told there are multimodal models where they can see images. And in the healthcare sector where I do a lot of my work, the idea is where these things are going to do. Godfather of AI stands up here and says, in 5 years, there'll be no radiology. Everybody knows it. It's as simple. Anybody who has eyes in their head can see that in 5 years, there'll be no radiology, right? Well, that was 7 or 8 years ago. There's more radiologists than there ever were. And it seems like they have a pretty good career path ahead of them. Why is this? Well, on the top is what everybody says, right? Top scores on medical benchmarks. These models, if they can get top scores on medical benchmarks, why aren't we using them in actual practice, right? And then this paper does a wonderful job of saying things like, here, this is the sort of thing that you get on a medical board. right? So they show you this, and then you have all the multiple choice questions, and the model gets it right, and everybody goes, oh, well, holy crap, like we can use this for diagnostics, right? And they're like, okay, well, what happens if we give it to the model without the image? And the model also gets it right. If you then say, well, why? Then it gives you a bunch of stuff that is not anywhere near the correct reasoning. This paper shows that demonstrates that same point, right, across huge numbers of benchmarks. So for all kinds of visual recognition and all kinds of systems. And moreover, what they show is that they could train a 3 billion parameter, which is relatively small, model without the images, but just on the questions for visual benchmarks. And it outperforms the frontier models and humans. So all of which is really good evidence that these things aren't reasoning, and they're not making their decisions on the basis of these images. The people who make these things are always like, well, what distractor should I use? Because it's probably like this, you know, like you think of this if this is the right question, and there's patterns in that allow you to guess the right answer. So I think that this leads us to underestimate when these things are safe. So that people want to say something like, hey, let's look at the task characteristics. So if it doesn't require something like understanding, then it might be safe. But the more understanding that it requires, then that might be higher risk. But I think that's actually the wrong way to partition the problem, that it's going to be something like, what's the probability that the output is in the distribution? And so you can ask it to do things that, down here that looked like they would require understanding. But if in the distribution of the text that it's seen, what you want is well represented, then it will reliably give you that output. But if what you want is to do something that's new, something that isn't well represented in the mean of the output, then these things are going to struggle. So the impact that that's going to have on science is that it's going to reduce novelty, homogenize all kinds of things. They can simulate reason, but they're not genuinely reasoning. But we talk about it and we rely on them the way that, as though they are. And I think that this is part of, so at the end of the day, the unhealthy ecosystem around AI in science. And I've gone on very long, so hopefully there'll be time for one question. But thanks very much.
I think we've got time for a question or two, if anyone has questions. I would say from my perspective of seeing folks kind of pragmatically try to engage with these systems as scientific assistants of one form or another, what would you think of as evaluation procedures, institutionalizing them that you haven't seen yet, where you'd say, this is a process that I could think of that could improve our abilities to understand the capacity for these systems to actually work in science?
I think the most troubling thing about them is that they're going to work the best in exactly the places where, like in testing and evaluation, like they're meant to solve benchmarks. Like that's like the prime thing they're good at, and they're really good at teaching when what we're trying to teach is the kind of, here's stuff is in a textbook, because it's seen all the textbooks and it can give you that kind of answer. And then it seems like it knows all kinds of stuff. But when you start to move now to the Pareto frontier, where it's like, now I need to learn something new, it's like, well, yeah, I haven't seen that. Like I'm actually a very conservative thing. I only know things from the past. And so if you're trying to generate something new where I don't have the data, then my reaction is going to be confabulate. So you get led to rely on this thing during education, but when you leave education now and you go out to do the thing that we want you to do, if what you're doing is a kind of repetitious task that's been done over and over by a lot of people, then you can use this and it will be really fruitful and helpful in a guide. But if you're an academic and you're expected to do something new, then the thing is going to lead you likely to recapitulate other people's work without giving credit to them, because it's just basically guiding you back to a bunch of old ideas. Now the hands go up.
All right, one more question here. Can you put your hands up again? Did I miss anybody?
Although I feel badly because I feel like there are other people who haven't been able to ask questions. All right, I have two related questions. They're basically the same question, but for two different contexts. So I really like your part at the end. Okay, we should be thinking about what's in distribution, out of distribution. So my question for you is, in general, from an ethical perspective, how do you determine what's in and out of distribution? I think many of the problems are that we don't predict that accurately. And then specifically for science, I mean, I think many of the problems are that we're saying AI can come up with things that we should have come up with ourselves. We just didn't. So that would be, I would kind of put that in the class of probably within distribution. And then maybe it's not helping with the out of distribution. But that doesn't mean there isn't a lot of stuff that wouldn't be really helpful. So I'm just curious how you, in both of those contexts, how do you define and figure out and measure, determine what's in and out of distribution?
Yeah, I think that's a particularly difficult question because it's in distribution for the text that it's been shown. And so if you've been trained on the internet, then the question is literally what are very frequent word pairings on the internet. If the corpus that Microsoft just has a new model where they say it's trained on entirely licensed material, so it's like, okay, great, what's in the training set? Because that's what I would need to know in order to have a sense of like what's in distribution or not. I actually think that models like this can be incredibly useful because there's a huge amount of stuff that we just don't share. Like in one place, people have proven one theorem, but they've labeled it like for management. And in a different place, I need to know that theorem because I'm doing ornithology or something like that. It's the same structure, but it's got very different labels, right? And so we reinvent these sorts of things. And hopefully models will be better at sort of being like, yeah, I can give you that structure because I've seen that structure someplace else. And that can be genuine like learning and progress. And I think what we'll have to do, what the change is going to happen is we're going to be better at thinking about problems as, that has the structure of something we've already solved versus, this is an unsolved problem. And so it's not the sort of thing that it's going to be helpful to give to AI.
But they do seem really good at solving in-distribution problems like Erdos math theorems, which have never been proved by any human. That's still, in your sense, in distribution. So I'm still having trouble with the same question.
It's not my sense. I mean, I wish I was an author.
Yeah, I
of those
agree.
Papers,
I like that characterization, but I'm still a little confused as to how you tell what's out of distribution, given the empirical fact that a number of mathematical discoveries are clearly novel and arguably still in distribution.
I mean, I think the real good question here is like, what makes a proof novel? Because like when you do proofs, right? Very often you're recapitulating prior structures. Like there's a bunch of heuristics. There's a lot of so like the fact that you can take those old approaches and wind up with a proof to something that other people hadn't done. That doesn't mean that it isn't important, but also it also doesn't mean, though, that it's particularly novel. Like you can prove something that hasn't been proved before using a bunch of techniques that are pretty standard. And so I think one question is like, how much do we know that's in our latent knowledge that we just haven't been able to articulate? And language models are going to be good at helping us do that. And then where do we need new concepts, new structures, new ideas? And I don't think that they're going to be very, very, very good at doing that. But I think when it comes to the question of like, hey, can I rely on this model to do something? What we have to know in order to answer that question is the task that I'm asking you to do in its distribution. And if you don't know the training data and you don't know the frequency of the specific syntax that was used to ask the question and the length of the reasoning that was used to generate, then you won't know whether it's in distribution or not. To me, the lesson to take away is that means there's much more risk to using these things than you think because it's difficult to know when you're in distribution and when you're out of distribution and how far.
All right, with that, I think we have to hold questions to the break. Thanks, Al.